So let's talk a little bit about vertex form, and I'm going to pull it apart just a little bit. And so here is an equation in vertex form, and I'm going to focus on this part right here and what makes it special. So we know that this, I'm not going to worry about too much about this part and this part right now. I'm going to focus on this. We know that this is equivalent to x minus 3 times x minus 3, which is a special type of binomial in that it's a binomial squared, right? And this can be really helpful to get things in this form because then, well, one, it tells us vertex form, but it does other things too that we'll learn later. Now, if I distributed this, expanded this out, right, I would get x squared minus 3x plus 9, or x squared minus 6x plus 9. This is what's called a perfect square trinomial. And you'll notice that this 9, that's a perfect square, and half of this is, the square root of this is 3, and half of this is 3. And all perfect square trinomials have that relationship in common, that b, this middle term, right, half of that squared is this second term, right? So one of the processes that we work with is called completing the square, where we take a moment to some time and we add a term, a constant term right here that allows us to make a perfect square trinomial, right? As you can see, I've already done this one over here, right? Where if you look to the right, it says fill in the blank to make a perfect square. And what they mean is they want you to add a number that would make this a perfect square trinomial. In this case, it would be 9. Let's look at the next problem and see what that looks like. Okay, and in all of these cases, the process, what you're trying to get to this point where you have x or y minus something squared, right? And so by looking at this, y squared minus 2y plus, we're going to add some number, right? And it's always going to be half of this number. And then we're going to take that and we're going to square it. So now this is a perfect square trinomial that we can factor or rewrite like this. And if you're not sure that you did it right, you can always square it back out and get y squared minus y plus 1, or y squared minus 2y plus 1. So you can see that that worked. Let's see if we've got another one here. In this case, we're going to say y squared minus, or x squared minus 10x plus some number, right? And once again, we're trying to get it to look like this, right? This sign will always be the same, and then we're just going to put half of this there, okay? Whatever half of that term is. So then we're going to say, oh, well, and then we're going to say 5 squared is 25. So by adding that 25, we made this a perfect square trinomial that will factor in this form. So now let's look at what that means in terms of graphing something. So I have this equation here, right? And it's in standard form, and that's nice. You know, I can see my y-intercept is -5 and all that. But I'm really much more comfortable graphing in vertex form. So what I'm going to do is I'm going to complete the square to look at that, to get it into vertex form. So I'm going to just scoot this guy over and not worry about that one at all for a little bit. Then I'm going to sit here, and I know that I want to make this look like this. And so I'm going to add half of this, right? So half of 4 would be 2, and 2 squared would be 4. So now I've added that 4 there. But now I've changed this equation so it's no longer equivalent. No longer equivalent. So what I need to do is fix it so that it is the same. Now, so I added 4 to the equation, so I'm going to subtract 4 over also on this same side of the equation, and I'm going to get negative 9. So now I've taken this standard this equation in standard form, and I've turned it into vertex form, and then I know that my vertex is negative 2, negative 9. And then that makes it a lot easier for me to graph it. I can just come over here and I can, let's see if I can do this on this. I can graph negative 2, negative 9, right? And then I can graph my y-intercept at negative 5. 1, 2, 3, 4, 5. And then I also know this one, that's 2 away. Right? And then I can probably fill in my picture a little bit by doing up 1 over 1 both directions. And there's my equation. Okay? And we did that by completing the square. Now, there's another way to, let's do that one more time real quick. Let's say that I have this equation, y equals x squared plus 10x plus 12, let's do plus 20, okay? And then I can say, okay, well, I'm just going to scoot that first one over a little bit. Okay. Now I'm going to think about what do I need to add there? And really going to my next step really helps me out. I know I'm going this way. And so I say, well, what's half of that? And I say, well, that's 5. Okay. And then I say 5 squared is 25. Now I've added 25 to this, so I'm going to subtract 25 over here, and I'm going to get negative 5. So now I have an equivalent expression that is in vertex form, and my vertex is the point negative 5, right? Negative 5, negative 5. And now I can graph.